In this video, we're going to create a Python script to create a 2020 aluminum extrusion profile in a sketch. Hey everyone, this is Matt with Learn Everything About Design, and in this video, we're going to carry on with our Learning API series by taking the next step. So in the previous 6 videos, we learned about the basics of object-oriented programming in the first video. We learned some of the different ways in which we can program in Python. Then we moved on to learning a bit more about the API in Fusion 360, where we learned how to get user parameters, we learned how to create them, we learned about unit conversions, getting input from the user, and ultimately we made a simple script that allowed us to hard code some values to create our user parameters for things like draft and wall thickness. So the next step here is for us to learn how to begin to create our own objects. Now, when I say create objects, what I mean is things like sketches and features. So this example is probably a little bit more complicated than it needs to be, but it's a real world thing that I know is very common. So what we're going to do is we're going to learn how to create this 2020 aluminum extrusion profile in an API or a script that you can run. So there are a handful of things that we need to learn. In the description of this video, you can find a link to download this design. You really don't need it, but the main reason I put it there is if you want to do this on your own, the best thing that you can do is figure out a profile that you want to create, sketch it, and then begin to plot its coordinates. Now, in this case, what we're going to be doing when we're creating lines, we need a start point and an end point. So I have a spreadsheet that I created to begin plotting where this first point is, the second point, so I knew exactly where this line had to be. Then I go from this point up to this point to create another line and so on, working all the way around. And the benefit of this design is the fact that we only really have to worry about 1/8 of it. So if I draw a line directly in the middle, with the exception of this arc, everything on this left side here is just a mirror of everything on the right side. So as soon as we begin to figure out how to get all the way up to the point where our arc starts, then the x and the y values flip in order to go over here. So this first point is x is 0, y is 3.1 millimeters. This last point is x is 3.1 and y is 0. So what we can do is we can program in the first set of coordinates. We're going to hard code in the arcs in the corners by their start point, their center point, and the sweep. In this case, it has to be in radians because the units in the back end are going to be in centimeters and in radians. So from here, what we're going to do is we're going to just have that basic understanding of those points that we're going to plot. And if you want to do this on your own, I suggest that you go in and you create a spreadsheet where you plot the x and y values all the way up to the arc. And then after the arc, you can see that the x and the y flip. And that's what we're going to do. We're simply going to create these variables in an array, and then we're going to flip them around. And instead of doing something like a mirror or a pattern, we're going to continue to use the same logic. But as we get down to this second section here, the x values are still positive, but y is now negative. And as we get to this third one, they're both negative. And then the last one, x is negative, but y is positive. So that is the basis for how we're going to approach this sketch. By plotting each of these points, we're going to create these 3D points, and then we're going to create lines between them. Now, the next thing that we need to understand is going to be how we can do this in Python. And the way that we're going to go about this is very similar to how we learned the API when we were creating our user parameters. What we're going to do is we're going to learn in baby steps how we can access the sketch, how we can create a sketch, how we can access a sketch that's already open, how we can add lines and circles and arcs and all that kind of stuff. So to get started, again, you can have this design if you want. You don't really need it, but if you want to try to follow along on your own, then you can go through, pause the video, plot all of these points, so that way you have a good understanding of exactly where everything is. So let's get started by creating a new design. It doesn't really need to be a new design, but we're going to be creating sketches, and I don't want to clutter up the other design. We're going to leave the units at millimeters, so we're going to stick with the metric system. It's going to be easier because when we're hard coding values, we're going to be using the centimeter value, which means we just have to shift the decimal point one place. We're going to go to utilities, we're going to go to add-ins, and we want to create a new add-in. And again, I'm going to say API just to keep it at the top of my list. And I'm going to call this one Learn Sketch. And we're going to create this. I'm going to hit enter to accept it. And then I want to edit this. If you are just doing this for the first time, likely you'll want to trust the author. Now, I say that because we are creating this script on our own. If you're just downloading a script, then you want to be very careful that you know where it came from. The ones that are on the Autodesk App Store for Fusion 360 are already looked at, they're scrutinized or gone through. But if you're just downloading something off of a random website, you should be very careful. So every time we start a new script in Fusion 360, we get a handful of things done for us already. We're importing Autodesk Core, Fusion, and CAM, which we're not going to use, and Traceback. This is going to help us with error messages. Then we have this def run section, and this function is going to be the area where we are doing all of our code. Now, we have seen from our first video the basics of actually creating these functions and going about it in that manner. I'm just going to simply do everything in this try section and leave the rest as is. So every time we start a new script, we have this app, which is a variable created. It could be any name, but app is sort of the default. Autodesk Core application get. So what we're doing is we're getting the application object and we're returning it. Now, if you try to run this and Fusion isn't open, you're going to get an error. The next thing that we're doing is we're calling a variable UI. Again, it can be any name, but UI is just the sort of the standard one. And that's going to be equal to the app, which was, again, this core application, dot user interface. So this property gives us access to do different things at the very top level with the user interface. Things like put a message box out, ask the user for input, things that we've already explored. So I'm going to get rid of this UI message box. We don't need it. And I'm going to just add a little bit of space here, remembering that Python is very sensitive to indents. So what we want to do is we want to think about the process in Fusion and what that really means for us in terms of code. Remember, we're trying to create a sketch. And if we go back to Fusion for a second and we think about the process of creating a sketch, well, generally we just click the Create Sketch button, but in the back end, it's a little bit trickier than that. The sketch belongs inside of, in this case, the root component. The top level component, this unsaved, is automatically created and it's automatically active unless you create another component. This root component is where things like the origin, the planes, the sketches, they're all going to be saved. So before we can ever create a sketch, we are going to have to access that information. So the way in which we do this in the API is we think about it logically. So what I'm going to do is I'm going to call this next bit the design. And again, this is just a name that we can come up with. Design is kind of the stock one that you see in all of the samples inside of the API help. And the design is going to be equal to Autodesk ADSK.Fusion.design. So as we start to type that, you can see here we've got design, we've got workspaces, we've got draft features. There's all kinds of things that live at this top level. But design is what we want access to. And then we're going to cast it. And by cast it, what we're going to be doing is we're going to be casting it to the active product. So app, which is our application, dot active product. Now, the reason that this is important is because the product, you can think of the product a little bit like the different workspaces. We have CAM data, we have design data, and that active product is going to be where we are in Fusion. And casting it really just means telling the software specifically what it needs to inherit. Now, generally what happens is we're casting things like variables. We're casting like a string to be an integer or an integer to be a string. But in the top level of this, what we're doing is we're actually casting this design to be whatever the active product is. Now, some of the products, like CAM, for example, we can't just create sketches at the top level. What we end up doing is we have a manufacturing model, the same thing in like simulation and simplify, or in generative design and edit model. These are areas where it's a little bit trickier. There's a deeper dive that has to happen. But for us in the design, exactly where we're going to be, what we're doing is we're accessing Autodesk Fusion Design and we're casting it to the active product, the design workspace where we are. The next thing that we need to get is we need to get our root component. And again, we're making up a name, but it's really helpful to just come up with some standard names like app, UI, design, root component, sketches, features, things like that you're going to use over and over again, and it will simplify the code and it'll help you reuse some code. So now we got root component, and the root component is going to be equal to our design. And the design, again, what we're doing is casting that active product dot root component. So you can see here the names are pretty consistent. And if you have trouble finding these, they really come up in the help file. We'll take a look at the help file in just a minute. But at this stage, just try to follow along with what we're typing and what we're doing, and we'll circle back and make sure we understand it. The next thing that we need to do is we need to create a container or some sort of reference to sketches. So again, I'm going to use sketches as the name I create, and that's going to be equal to our root component, which is again something we just created as design.root component, and it's going to be .sketches. But here's the thing, before we get too far, let's look through this list so we can kind of get an idea of what is in this list. So under the root component, we have things like our joints. You see that we've got attributes, bounding box, we've got construction axes, planes, and points. If we keep going down, everything that has this wrench icon, you see that we've got description. We can pull a description of the root component. We have got features, we've got ID. And the ID information is going to be based on the components themselves. We've got some joint origins, mesh bodies, and so on. So you can kind of see a lot of these wrench icons, a lot of these different things that we can access at this level of the root component. We can change its opacity. We have things like the parent design, if there is an external link, for example, revision ID. And you can see that we get down here to something called sketches. And also below that, note that we've got construction axes and construction planes. But in this case, we're creating this variable sketches, and we're going to associate it to the root component .sketches. So at this stage, what we've done is we've got our application, we've got our user interface, again, so we can pass things back and forth like messages and ask for input. We've set up our design as the active product, and we set up our root component as the root component in the design. Now, of course, you could access various components in a design, but then you'll have to do things like search through the design for what components are available and have some sort of logic to sort of pick back through and figure out which one you want to activate. We're only looking at the very top level of this for our example. Next, we set up our sketches as the root component .sketches. So again, we're beginning to start to access these different things. What I want to do at this stage is I'm going to open up the help file and just kind of remind ourselves of this object model. Now, I have it open here. You can find a link in the description to the help file. But this object model, again, is sort of telling us at the very top level, like the user interface, for example. We have accessed the user interface already from the application. And as we look down through here, we can do things like create message boxes. We can send a message to the user. We can ask for input. And that's really a very general example. But you can see that we've got other event handlers, things like input, changed event, command event, and so on. And we've got other things at the very top level like application command events. And this is the way in which we can access all of these directly from user interface. So anything that is connected directly to this vertical line can be accessed directly without having to sort of associate them with any of these further down objects. When we go over here, you can see that we've got our document. And as a reminder, if we take a quick look back at our program, we've got our document, and we've got our root component, and we've got our sketches. Now, at some point, the names or the terminology get a little bit lost. So document is essentially like a file or a design. So a document, think of that as anything that you would find as an individual item inside of the data panel. But from the application, this document we have, our Fusion document is our design. And then you can see here design A. This is what we created. The design A was the current active product. And from there, we can directly access things like the export manager. So if you wanted to save the design out as an IGES or an STL, that already is accessed directly from the design. But we're going down deeper than that. We've got component. And from component, we are going to be coming over here to the right to sketches. And from sketches, we need to go down into sketch curves and eventually to sketch lines. So this is the process of going down through these lines. And if we are in the help file and we're trying to figure that out, we just don't really know where to go. The first step is to go to the sample programs. More likely than not, there'll be a sample program that'll help you get that little piece of information. So for example, if we go into the sample program, we go into modeling to sketches, and we look for either a sketch sample or one that's a sample of sketch lines. So here you can see API sample that demonstrates creating sketch lines in various ways. So if we click on this, we've got Python and C++, and we can see that they've got the app, the UI, these are all things that we have. They have a document, and then they have this design as the active product. Now, this document is a little bit interesting because we are not doing this step. We're not creating this documents add, and this is because they are, in this example, they're creating a new design. They're creating a new untitled document. And we don't have to do that because we already have one open. And remember, we cast it to the current active product because we're just using whatever is already open. But so when you look at this example, you have to think about what is it that they're doing. And the documents.add here is again, it's creating a new document. As we go down, they access the root component, just like we did. And then the next step for them is sketches, root component.sketches, which we did. And then they create something called the XY plane. And then the sketch is sketches.add using the XY plane. So what they're doing here is they have created a sketches variable, which again we have. They created an XY plane variable, which we don't technically need to do. We can do this root component construction plane inside of the brackets. And they're creating a brand new sketch. And from there, you can follow down. They're beginning to access sketch curves, sketch lines, and then they're building lines. And they're creating constraints, and they're adding horizontal and vertical constraints, and so on. In this example, we are not going to get into adding any constraints. That's going to be a bit past what we're going to be doing. Our entire sketch is going to be under constrained. There's going to be no dimensions. There's going to be no constraints. So just keep that in mind, that if we go back to this sort of PDF here. So keep that in mind here. If we want to add the dimensions and the constraints or anything else, that's accessing a whole nother category. So for this example, we're going to stick with sketch and sketch curves, and that'll give us everything we need. So back in our code, now let's think about the next step. So we have sketches.root component, or I'm sorry, root component.sketches. The next step for us is, just like in the example, is to add a new sketch. So we're gonna approach this from two different angles. The first angle is to add a new sketch and create sketch entities, a line and a rectangle inside of it. Then the second step is going to be to look at the current active editing sketch, the sketch that you have open already, and then we're going to add our sketch elements to that. And there are two reasons why I want to cover both of these. The first reason is because most of the examples will create a new sketch and create new sketch entities, so it's important that we go through that and we understand it. The second reason is that if we already have a sketch open, it actually, in my experience, my limited experience with this, it will actually help us in figuring out the next step inside of Visual Studio here. So what I'm going to do is I'm going to create a new variable called sketch. I don't want to use sketches. I've already assigned that to the root component.sketches. So it's sort of think of it as a container or a bucket that's going to hold all of the other sketch pieces underneath it. So this new one, sketch, is going to be equal to sketches, which is again our root component.sketches, dot add. And inside of the brackets for add, what we're going to do is our root component dot XY construction plane. So in the example, what they did was they created a variable called xy plane, and then they assigned it root component.xy construction plane. We're just sort of skipping a step. Now, really, we could have gone a step further and we could have said sketch, I'm just going to use sketch 1 so it's not the same. We could have said that this equals root component dot sketches dot add, and then done the exact same thing. The reason that we didn't do that is basically going back to our hierarchy. When we go back to our hierarchy, and I'll bring it back up just for a second, if we come back to this list, if there is this sort of a divergence or a break point where we might need to access dimensions, constraints, curves, profiles, anytime that we have this sort of object where there are multiple branches off of it, that's a case where we want to do something like define sketches, because now we can do our sketch equals sketches.add, and we could do something like our constraints. We don't want to do constants. Constraint equals sketches dot dimensions or something, something along those lines. So not a great example, but I'm going to go ahead and put this back. So that's the reason why sometimes we want to take these extra steps of calling these additional properties with these variables that we create, because we might need to branch off to access other things. So now that we have our sketch, which is equal to sketches.add root component construction plane, in the software, if we were to just run this, what we're doing is we're creating a new sketch. So let's go ahead and save it, and let's just do a quick test in the software, remembering that we call this API learn sketch. So in Fusion 360, I don't have any sketches in this design. If I go to my API and go to API learn sketch and run, I now have a sketch. The sketch should be on the XY plane, but it doesn't contain any geometry. We haven't really done anything with it. So we know that the first part of this is working. Let's go back to our code and let's see if we can add something to it. So now that we have our sketch, I'm going to add another space here. Now that we have our sketch on the XY construction plane, or we know that the script is going to be able to create that new sketch, let's go ahead and access it. Now there are a couple different things that we should keep in mind when we do this. And again is going to be the sort of the branch point. Now what I mean by that is what we could do is we can create a new variable called sketch lines. And honestly, at this point, the word sketch looks so weird to me because I just typed it so much. But sketch lines is equal to our sketch dot, and here's where it gets a little tricky, because the way in which we're doing this now by creating a new sketch inside of the program, we're not going to get these little pop-ups like when we did dot add here that help us along the way. So when we're doing it this way, we need to have the help file open or an example, or we need to know exactly what we need to type in order for this to work. So in this case, from that object model PDF, that map, I know that we need access to sketch curves, if I could type that right, sketch curves, and under sketch curves, this is sketch lines. And if we go back again, just real quick, we'll take a look at it. I'm going to zoom in a little bit and bring this over. That's probably still too small to see. Let's make it a little bit bigger. So we have our sketch, sketch curves, and sketch lines. So this is what we're working toward. We're working toward getting down to the sketch line so we can create a sketch line. So back in our code, back in our program, again, doing it this way means that we don't really have those helpful little things pop up. And part of that is based on the programming interface and the way in which we're accessing different objects. Now, I'm going to show you another way in a little bit where it will help us along with that. But for right now, let's just stick to this. So we've got our sketch lines, which is equal to sketch.sketchcurves.sketchlines. We've sort of worked our way down from the design, the root component, the sketches, and we've added a new sketch. So now we're inside of our new sketch, which is right here. And we've accessed sketch curves, which is part of this root component sketches, and sketch lines. And the reason that we can do this is because sketch is accessing sketches.add already. So it's already part of that, let's just call it a family. So the next thing that we can do is we can determine and define the starting and the ending point for our line or our rectangle or whatever we're going to create. So I'm going to create a new variable called my start point. And again, sort of standard nomenclature here. The start point is going to be equal to our autodesk.core.point3d. Now, point3d is a little bit interesting because it doesn't really belong to sketches. It doesn't belong to features. It's not one of those objects where we have to sort of drill down the hierarchy in order to get the parent-child relationship. This is one of those variables that can kind of live at the very top on its own. It's a container or a holder for these 3D points. And even though we're in a 2D sketch, yes, we still are going to be using 3D points. So autodesk.core.point3d dot create. So we're going to be creating a 3D point. And this first one, I'm just going to put 0, 0, 0. So that's X, Y, and Z 0. Then we're going to create one called endpoint, same nomenclature, adsk.core.point3d dot create. And this one is going to be at 550. Now remember, this is centimeters, so we're at 50, 50, 0. Now that we have our sketch lines, our start point, and our end point, the next thing that we need to do is we need to create a line or a rectangle, something. And the way that we're going to do that is by using sketch lines. Sketch lines hasn't been used yet, and neither have the start and the end point. So in this case, we don't need a new variable. We don't need to set it equal to something. We simply need to say sketch lines, which is the variable we created, dot add center point rectangle. And again, here is where it gets tricky because we don't have those little pop-ups that are helping us figure these out. And then this is going to be our start point and our end point. So what we should have done at this point is add a center point rectangle where center is at 0, 0, 0, and its corner point is at 550. Let's go ahead and save this, hop back into Fusion, and give it a quick test. So you can see right now we've got a sketch. We're not currently editing because we don't see our sketch tools up top. We don't see our sketch palette. So add-ins, API learn sketch, run. Now we have a new sketch. The new sketch contains a rectangle. And I bet if we use I for our measure tool, and we measure from that corner to this corner, you can see that it's at 50, 50. Remember, 5 and 5 is centimeters. So it's at the XY position, 50, 50, 0, because Z is in 0. So we know that it's working. Let's hop back into the code and let's add another one. Sketch lines dot, and this time we're going to just add a line. Add by 2 points. Now, again, all of these are coming directly from the help. So you need to know exactly which piece of information you need. I'm going to go ahead and add endpoint here. We're going to save it one more time, minimize it. I'm going to hide this sketch, go to add-ins, API learn sketch, run it. And now this new sketch has the same add 2-point rectangle or center point rectangle. And it also has a line going from the start point 0, 0 to that corner point 50 millimeters by 50 millimeters. So we know that everything is working at this point, but that was a little tough for us to do. We had to go through, we had to create a new sketch, we had to pick which plane it was going to be on, we had to begin to access all of these different variables, sketch lines, sketch curves, and so on. And then we had to do these add center point rectangle and add by 2 points for the line. And we didn't know what those were. We had to go digging through the help file, or I had to go digging through the help file, and we had to know exactly what to type because unlike up here when we had point3d.create, we didn't have all those little helpers, those things that told us, well, we need an XYZ point. Or up here, when we were getting the application, it didn't tell us that the method.get was what we were accessing. So there's another way that we can do this. and it's going to involve us accessing a current sketch that's in edit mode. But first, let's make sure that this is saved. Take a second to just pause the video, go through what we did, and just make sure that you're familiar with the process of going through. We've got our app, our UI, our design. Remember, thinking of the design as the current document that we have open and the current workspace that we're in. The root component, which again is the very top level of the browser. Sketches, we created or we accessed the root component sketches, which would be essentially the folder that all the sketches are contained in, but really it's more than just the folder. And then from there, we created a variable called sketch. In that case, we accessed sketches.add to build out a new construction plane based off of XY. Then I shouldn't say a new construction plane. I should say we added a new sketch on that construction plane. Then we have our sketch lines, which we're accessing sketch, which was the new sketch we added. And inside of that new sketch, we accessed sketch lines, which allowed us to do things like add center point rectangle and add by 2 points. But again, the way in which we accessed all these little bits of information can give us different results. So the next example we're going to do is we're going to start another program. We're going to leave this one exactly as is. We know how it works, but we're going to copy everything that we did here and we're going to paste it into a new program, and then we're going to hack it up, and I'm going to show you a better way. So again, make sure everything is saved at this point. Make sure that you understand what we did, and then let's move on to our next example. So once you're comfortable with what we've done, we're going to select everything and we're going to copy it. So we're going to go ahead and do Control C. I'm going to leave it up, but go back to Fusion and go to my add-ins, and I want to create a new script. So this one again is going to be Python. We're going to do API and learn sketch used. You can call it whatever you want, but essentially what we're doing is we're going to make a new script that makes use of a current active sketch, something that's currently being edited. So we'll create, we'll hit enter, and then we'll edit. So again, we'll have to trust the author. I'm going to select everything here, and I'm just going to paste our current content. So this is exactly the same program that we've already made, and what we're going to do is we're going to start to modify it. And what I mean by modify it is instead of us building out a new sketch on a construction plane, we're going to build out a sketch on a current active sketch. So we're going to just make use of whatever's being edited, and then we can use this to input our sketch entities. So a couple things are not needed anymore. We're not going to need this, the sketch. We're going to go ahead and put the pound sign in front of it to turn it into construction, and that's going to break a few things. So you'll notice that we now have some squiggly lines under sketch, and it's telling us that that is no longer an available variable. It doesn't exist anymore because we commented out. And you'll also notice that sketches, this variable we created up here as the root component.sketches, is grayed out because it's no longer used. It was used in here to add a new construction or a new sketch on a construction plane. So what we're going to do instead is I'm going to make a little space here, and I'm going to tab over to the right position. We always want to make sure that we're mindful of the tabs when we're using Python. Now, instead of us creating a new sketch on a construction plane, we want to access the current sketch. And there's a couple different ways that we can do this. So I'm going to type it out 2 different ways, and we're going to try to just take a look at the syntax so you can decide which is easier. So the first way is for us to type in sketch. I'm going to use the same name, and I'm going to do a colon space adsk.fusion.sketch. So again, we're going to come to there, and then inside of this, we're going to hit equals, and then inside of this little container that we're building here, we are going to say that the app dot active, in this case, edit object. So active edit object is going to mean that our sketch is the one that's currently being edited. And we'll go back after the fact and we'll add some conditions to make sure that it is actually a sketch. But for right now, we're going to assume that we know what we're doing. We're going to assume that we're in a sketch, and that is going to be how we access this. Now, the syntax there is a little different than we've seen before. We haven't really typed in a variable and used a colon before. So just to make sure that we understand what this is, there's another way that we can do it. So I'm going to put my, my pound sign in front of it so that we can comment it out. And now I'm going to type in sketch, again using the exact same name, equals adsk.fusion.sketch, just like we did before. But instead of doing equals app.editObject, what I'm going to do is do a cast. And then inside of my brackets, I'll do app.activeEditObject. So these two things are saying the exact same thing. Now the difference is when we are using cast, what we're doing is, again, we're taking it, in this case, we're taking our sketch and we're casting it to the active edit object. So the active edit object, if we've done this right, should be a sketch. So this means that we don't need the sketches root component.sketches anymore because we don't need to create a new sketch. I can go ahead and comment that out as well. So once again, these two are saying the exact same thing. It's just a different syntax to get there. One other thing happened that you may or may not have noticed. So let's take a look down here at our sketch lines. So when we originally typed these sketch lines out, the add center point rectangle and the add by 2 points, those were just white text like everything else. They weren't green. We didn't have those helpers. But now that we've actually cast the active edit object into sketch, they're starting to make sense because our sketch lines are part of sketch.sketchcurves.sketchlines. So let's retype some of this. I'm going to comment that out and I'm just going to retype it. So sketch lines equals sketch dot. Now when I put the dot here, we have something that we can look for. Sketch curves, tab to select it, dot, sketch lines. So we're just going to pick sketch lines and hit tab. So now you can see that the way in which we're accessing the sketch, instead of creating it from scratch in the API, what we're doing is we're just accessing a current sketch. And this actually, the way that it's done, because we've cast it onto the current edit object, we're inheriting those commands, those methods, those functions. And they're a lot easier for us to figure out. So for example, if we wanted to add more sketch lines, which again, sketch lines is our sketch.sketchcurves.sketchlines, again in that hierarchy. If I do a dot, now I can see all the different things that I can add. Add by 2 points, which is a line, add center point rectangle, distance chamfer, 3-point rectangle, and so on. So now we have a good idea as to what those are. So I'm just going to delete that. We don't actually need it. And let's try this out. Let's see if this works. So I'm going to save this. Going to go back into Fusion. Now, remember, what we're looking for now is a current active edit sketch. So I'm going to start a new sketch. Just pick a plane. Go to my utilities. Go to my add-ins. And we're looking for API learn sketch used, and we're going to run it. So now it builds this out exactly the same as it did before. So remember, sketch 3 was done on the default XY plane. And this new one, I just picked a new plane and I stuck it on there. So if we finish the sketch and I start a new sketch over here, now we can go to utilities, add-ins, run the same program again, and again it builds it. One thing you'll notice happens here is the line direction does not really make sense. And that is an important consideration that we have because when we talk about our coordinate systems, the coordinate systems are going to be different in the model and the sketch. So let's go ahead and hide a couple of these sketches. Let's get out and finish that sketch. And I'm going to start a new sketch on the XY plane. So let's go ahead and start the sketch. When we look at it in the XY plane, X is pointing to the right, Y is pointing up. That's the default coordinate system for a Z up orientation. So if I run the utilities and I run that API and it's printing out this point up here at 50, 50. 50 in the X, 50 in the Y. That's exactly where I told it to be because X is to the right and Y is up. Well, that's not necessarily true in all cases. So if we go back to our solids tab and we create an offset plane, we just put a plane out in space somewhere and I start a new sketch here. When we start that new sketch, notice how it rotated our view. Y is to the right and Z is pointing up. But the trick here is if we hide the origin, we have a red axis to the right. So X is to the right and Y is up. But our default origin has Y pointing to the right and Z pointing up. So if we run our utility now, you can see that in the XY orientation of the sketch, X being left and right, Y being up and down, we're getting that positive 50 and 50. So we're getting exactly what we expect. However, the trick to this is if we look at the coordinates in the bottom right, X is actually at 120 millimeters because we're in an offset plane. Y is at 50 and Z is at 50. So the coordinates that we're entering for X, Y, and Z are relative to the sketch coordinates, not the model coordinates. If we sketch relative to the model coordinates, it gets a little bit tricky, especially when we're dealing with offset planes, because as you can see, X is 120 in this case, but in reality, in the sketch, it's actually only 50. So it's another aspect that we kind of have to keep in mind, and it can get tricky. There are commands where you can convert the different coordinate systems, model to sketch and sketch to model. We're not going to be going over those, but just note that there is a way for you to do that. So that was sort of the second step in this process, was to understand how we can create the different objects that we need. You can even see that root component is now grayed out because there's a lot of stuff that we just don't need when we're casting to the current active edit object. It makes the programming that much easier. So I can get rid of root component, and you'll even note that design isn't used anymore. And design isn't used anymore because we are casting sketch to the active edit object. And that active edit object could be editing a feature, could be editing a sketch, could be editing whatever. But because we're automatically casting to that, it also means that we didn't need to go through the whole hierarchy of design to root component to sketch to all that stuff, because we sort of took a shortcut to get there. So what I'm going to do is I'm going to get rid of a bunch of these little pieces. I'm going to save this, and we're going to start a new program. So when we start a new program, what we're going to be doing is following this same approach where we're casting to the active edit object. We're going to cast to the same one. But in this case, we're going to start to learn a little bit more about arrays and programming in the coordinates and actually building something in 3D. So once yours is saved, let's go ahead and hop back into Fusion 360. All right, so once again, we want to create a new add-in. I already have one called 2020 AL 20 millimeter, but I'm going to create another one that's similar to that, Python. I'm going to call this one API. Now, note that the 2020, it's going to be numerical before alphanumeric, so it's not going to be all the way at the top, but I'm going to call this API 2020 AL. And that'll just remind me that I'm creating a 2020 extrusion. I'm going to hit enter to accept that and then go ahead and edit. Once more, we need to make sure that we trust the author in this case because it's us, and then think about what we need. So first, we know that we don't need this UI message box. Next, I'm going to just make some space for us to work. We don't need to really worry about the exception. And then typically what we would do is we would create that design, which is equal to adsk.fusion.design.cast and the app.activeProduct. So again, this is helping us cast the design, the current open document, to the workspace that we're in. We're in the design workspace, the current active product. It's gray, and honestly, it's going to stay gray because we're not going to need it for what we're doing. However, if you continue to develop this program and you want to, say, extrude your profile, or you might want to access something else, it's good to have this in the code. Even if we're not using it for right now, it's good to have it. And that's also the same with our root component. So let's go ahead and just put root component in there. And I'm going to say that that is equal to the design.root component. And again, I don't need it. It's not something that is required for the steps that we're going to take to build out the sketch. However, again, it's good to have because remember, there are a lot of different branch points where we can sort of change directions. Now, what we're going to do is we're going to put an if statement that is going to check to make sure that our object type is actually a sketch. So this is not something that we put in our last program. However, it is pretty important. So we're going to do an if statement. And if you don't have any familiarity with an if statement, essentially what we're doing is we're creating a conditional check. We're saying if this thing is true or if this thing is not true, then do something else. So in our case, we're going to say if the application, which is Autodesk Core application, dot active edit object. Remember, that's what we use to get access to the sketch. If that dot object type, because this variable is going to return the object type. If that object type does not equal what we should expect for a sketch, then we need to do something. The way that we say not equal in pretty much any coding language is exclamation point equal. So that's going to tell us if it's not equal, and then we need to tell it what it's not equal to. adsk.fusion.sketch.class_type. And then we're going to close some brackets, and then we're going to put a colon. So essentially what we did here is we said that if the current edit object, the current active edit object, its type is not what we expect to see from a Fusion Sketch class type, so it's going to check what the current object is and return the class type as a string. And then it's going to take a look at this and return this as a string. If they're not equal, then the next thing that we put in the code is what's going to happen. So if they're not equal, then we're going to prompt the user. So UI.messageBox, and we're going to say, hey, you know what? You need to select a sketch. So we're going to say a sketch must be active, and then we'll hit enter. Remember, the tab or the indentation is incredibly important in Python. So anything that's tabbed in from this if is going to happen inside the if statement. So what we want it to do is say return. So what'll happen is it's just going to finish. It's going to hop out of the if statement. It's going to finish the program until we correct something. We're not going to go through the process of putting a bunch of logic into this, but this at least gives us a warning that says, hey, you need a sketch. What are you doing? You need to select a sketch. This isn't going to work. So now that we're out of the if statement, we're going to hit backspace so that we're back in line with that if statement. And I'm going to hit enter just to give me a little space to clear everything out. So the next thing that we're going to do is, again, we're going to create that sketch, the active edit object, and we're going to cast it into Sketch. Remember, there are two different ways that we could do that, right? So that's going to be sketch : adsk.fusion.sketch, and that is going to be equal to app.activeEditObject. So that was the one way that we could do it, or we could say that the sketch was equal to Autodesk Fusion Sketch cast to the active edit object. So either way that you want to do it, you can go back to our old code and you can take a look at it. But either way that you want to do that will be fine. So if we take a look at this, again, this is the way that we just typed it. You could also do it equal to the same bit of code right here. So this little bit of code is exactly the same, except we're casting it to the active edit object. It's really up to you which method you choose. I'm going to type them both out here so that you could see them. So the equals ADSK Fusion. Remember, anytime you get something inside of the pop-up dialog here, you can hit tab to accept it. And .cast, and then in the brackets, we're going to say app.activeEditObject. And again, that's going to give us the same thing. We can only have one, but I'm going to leave both of them in here so at least you can see both. Again, tabbing is important. We need to make sure that we're in the right place. From here, now that we're in the active edit object, I need to define the sketch lines, just like we did in our previous example, but we also need to define sketch arcs because we are going to be creating a circle at the center of our profile, and we're also going to be creating an arc as the filleted corner. There are multiple ways that we could do this. You could add a fillet or a chamfer to the sketch, but it's going to be much easier because we're already traversing through the points to add an arc at that time. So we're going to create a new variable. This one's going to be sketch lines. And that's going to be equal to sketch, which is, again, the variable that we created that's cast to the current edited, the sketch that's currently being edited. Sketch dot sketch curves. And again, these are coming directly from that the hierarchy. And sketch lines. Because we have cast to the current active sketch, we have all these pop-ups that are giving us all the different pieces of the puzzle that we need. It makes it so much easier. So this time we're going to create a new one called sketch arcs. And that's going to be equal to sketch dot sketch curves, because we're accessing the same object as we go down through the list, and then sketch arcs. So now is the point in the program where we need to make a decision on how we're going to code this. The way that I'm going to do it is I'm going to create some arrays, and the arrays are going to be containers for information. When we originally did our first video and we were looking at the way in which we can interact with Python specifically, we learned about ways that we could put multiple pieces of information into a variable. So we had a couple things that were tuples. We had some different containers for data. So the way that we're going to do this is we're going to create some arrays. First, I'm going to create one called POS array. This is my position array. Now, if anybody out there who's watching this is a programmer, please note that this is probably not the most efficient or best way to do this. This is just a simple way to explain the process. So what we're going to do is create this position array, and we're going to use square brackets. Inside of the square brackets, we're going to put all of the values that we want. So I'm going to do 0, 1, 2, 3, 4, 5. The reason we do this will make sense in just a second. So we're going to hit enter, and then we're going to make an X array. And the X array is, again, equal to square brackets, and then we need to put all the values inside of here. So our first X position, if I bring back my, my document, so let's go ahead and bring this up. My first X position for my line is 0. Then my second X position is 2.25, then 5.5, 5.5 again, 3.1, 3.1, 8.5. Remember that these are in millimeters, and the values that we enter inside of our code, unless we do some conversion, which we've already taken a look at in the past, these are centimeters. So 0 is fine. Our first position at 0 is completely fine. But instead of 2.25, we're going to put 0.225. Then for our next position, we're going to do 0.55. Next position will be 0.55 again, because again, that was 5.5 millimeters. Then we're doing 0.31, then 0.31, then 0.85. So at this point, if you downloaded the data set and you measured all the points, you can see exactly where these are coming from. And we're going to repeat the process with the Y array. So the Y array is going to be equal to, again, square brackets. The first Y value is 0.31. The next one is 0.31, then 0.635, then 0.82, then 0.82 again, then 1.0, and 1.0 to finish this off. So as we look at this, we've got 1, 2, 3, 4, 5, 6, and 7 positions. Now keep in mind that with programming and with arrays specifically, the position of the item in the array is, the first one is 0. So if we ask or we call up the 0 item in the array, it's going to be the first item as we typed it out. The first item or the first position ID is going to be the second item, and so on. So when we look at our position array, we've got 0 through 5. So we've got 6 items, and we've got 7 inside of the X and Y array. And the reason I did it this way is because we're going to be using a for loop that'll help us pick out each of these positions so we don't have to hard code every line. We're just going to cycle through each of these. So the first line will be from 0.31 to 0.225.31. And if we go back to Fusion 360, back to the original sketch, that first line will be from 0.31 2, 2.25.31. And that's exactly how we're coding it. So what we're going to do is create this for loop that just simply moves its way through this. And remember, when we get through the first eighth of the design, then the x and y flip. So we can simply run through that for loop again, but instead of having an x and a y coordinate, we're going to have a y x. And then when we get to a negative space, we're going to have positive x, negative y, then negative x, negative y, and so on. So we only really need to make one for loop, and then we can sort of edit it from there. So now that we have our position array, which is going to be just used for our for loop, which is why we started with 0, because it's going to call up the first instance in our array, then we just need to build out the start point and the end point and the line that we want to create inside of a for loop. So a for loop, in most cases, will require you to have a predefined variable. However, in Python, that's not the case. So all we really need to do is say for space I, I'm just making up I as the variable, again, common terminology, in POSARRAY, and then I need my colon. I'm going to hit enter, which will automatically tab me in. Remember that Python is very specific about its position. So everything that we type now will happen inside of this array for each instance of I. So if you think about this, as we go through, the first thing it's going to do is go from 0. So it's going to pull out the 0 of the x and the y. It's going to go through the loop, create a line, and then it's going to go through it again and again and again. So the way that we make this happen is our start point, so we're just going to use the same terminology we used in our previous example, is equal to adsk.core.point3d.create. So we're building out this 3D point. We're going to put brackets, and we're going to say that this is X array, and we need to put some square brackets, and inside of the square brackets for X, we're going to put I. Then the second coordinate will be Y array, and again, inside of square brackets, we'll put the letter I, comma, because remember that these 3D points are X, Y, and Z, all of our Z values are going to be 0. So now that's our start point. Our end point is going to be equal to adsk.core.point3d.create. So same thing we did. However, now what we're going to do is X array, and inside of our square brackets, we're going to do I plus 1, comma, Y array, and again in square brackets, we're going to do I plus 1, comma, 0 for the Z coordinate. And then from here, we're going to do our sketch lines, which again was a variable we created, and it's going to be add by 2 points. And you can see because of the way that we cast to our current active sketch, all the information pops up for us. So add by 2 points, in brackets we have our start point and comma and our end point. So that's going to bring in XYZ for us. So as it loops through this array, what we're getting, again, is the first X and Y, is the 0 position. And then for our end point, what it's doing is it's taking our position array value I, and it's adding 1 to it. So for the end point, it's going to be taking, for this first instance, it's going to be taking position number 1, which is 225.31. And then as it loops back around and I equals 1, it'll pull those values, the 225 and the 31, as our start point, and then these values as our end point, which is why we can only have one less in our position array than we have in the actual X and Y array, because this is always going to account for the end point being plus 1. Now that we have our start point and our end point and our sketch line, the next thing we need to do is we need to build out the arc in the corner. So this is not going to happen in our for loop, so we need to hit a backspace, and we need to define the arc start and the arc end. The arc start and the arc end could be hard-coded in, but it's just good practice for us to do this. So arc start is going to be equal to adsk.core.point3d.create, same thing that we've been doing. And this time, we need to know where the start point is. And that's going to be the last point that we had inside of our XY array. So for this example, it's 0.85, comma 1.0, comma 0. Then the arc center, the way that we're going to define our arc is by center, start, and sweep. And there are a couple different ways that we can do this. We can do 3 points on the arc, we can do tangencies, but we know the start point, we know the center point, we know that it's 90 degrees, so this is going to be easy for us. So again, adsk.core.point3d.create, and our center point is going to be 0.85, comma 0.85, comma 0. And that's because if we go back and look at Fusion, we're starting here, which is 0.85 in the X and 10 or 1.0 in the Y. The center point is 0.85, 0.85, and then the sweep is going to be 90 degrees. Now, remember earlier I mentioned that the sweep is actually going to be in radians, and positive or negative determines if you're going clockwise or counterclockwise. So for us, we're going to just hard code the sweep in there. And this is going to be sketch arcs. This was the variable that we created. This is this one right here. Sketch arcs dot add by center start sweep, because again, that's how we're defining it. And in brackets, we start to define it. So we have our start, our center, our start, and our sweep. And again, because of the way that we cast onto our active sketch, we have the tooltip here that tells us we're starting at the center, then the start point, then the sweep angle. So our center point, this is pretty easy because we already defined all these. Arc center, it's going to be arc start. And then again, the radians we're going to hard code. Negative 90, or 90 in the clockwise direction will be minus 1.5708. So at this stage, we should build out everything up to and including the arc. So it's good for us to do a test. Let's go ahead and save this. Make sure that we're on the right track. We're going to go back to Fusion. We're going to go back to an untitled document and just create a new sketch. Because remember, we need to be in an active sketch. Then we're going to go to our utilities. We're going to go to add-ons. And this is our API 2020 AL. When we run this, nothing really happens. And that's because the old ones we punched in directly as centimeters, as very large numbers. So if we zoom in, you can see that we've got our design here in millimeters. If we select the center point of this, you can see that it's at 8.5 by 8.5 millimeters. So this is the first roughly eighth of our design. We've done all the hard work, we know all the coordinates, and now we can continue on. So the next thing that we're going to do back in our code is copy everything we've done. Everything in this for loop and everything including the arc center up to a point. So we have to remember that the for loop is everything up to the arc, and the arc is hard coded. So what we really need in order to get a full quarter of our design is this for loop repeated after the arc center. So we're going to come down here and we need to make sure that it's at the correct indentation. So I'm going to do Shift Tab, and then I need to do a Shift Tab in front of this, select all this, and make sure that it's tabbed in, because the spacing, the tabs is all very important whenever we're working in Python. But if I just put this in here again like this, what's going to end up happening is it's going to build the exact same thing. So the way that we do this is, now that we're flipped over the mirror line, the first coordinate is going to be y, and the second coordinate is going to be x. So we're going to just switch the x and y around. We're going to save it, and we're going to go back into Fusion and test it. So I'm going to finish the sketch, I'm going to hide it, and I'm going to start a new sketch. I'm going to go to Utilities. Let's go over here. Utilities, Add-ins, API 2020 AL. So there we go. Now we've made from this upper right quadrant, we went all the way around the design, and we came all the way back to here. At this point, you could do a circular pattern of the sketch. You certainly could access that through the API, but we have all the code done to build the rest of this. We just need to know what X and Y values we're working with and whether they're positive or negative. So let's go back into our code. So now in the code, this little block that we created right here, it's going to get repeated 4 times. So I'm going to copy everything here. I'm going to come down with a space and I'm going to paste it. But the trick of this is, right now we ended on these values where everything was positive. We went xy, xy, yx, yx. To get to the next point, we need to go positive x and negative y. And if you need to verify this, we're starting from this point right here, which is 3.1 millimeters and 0 in the y direction. So it's tough to think about, but we need to think about it in the context of the x and y axis of the sketch. You can always use measure and inspect and figure out where things are relative to each other, but we know that we're going positive x and negative y. So when we look at our coordinates, positive x is going to be 3.1. Because we're still at yx from our last example, it's going to be positive 3.1 and then 0 in the y direction. Another thing that you need to keep in mind is that we don't have to build it in order. We just have to make sure that all the lines are accounted for. So we're not going to see these being built. It happens so fast that it all just pops on the screen. So whether or not we start at 3.10, or if we start completely in the bottom section of the quadrant and work back up counterclockwise, honestly, it doesn't matter. So it's just however you can visualize this, for your own code. So I'm going to just keep using this block because it's going to be easier for us to just copy and modify. So what I'm going to do is I'm going to change the y to be negative in this first section. I need to change the position of the arc start and end, because now instead of 0.851, we're actually starting at 1.0 and we're going to minus 0.85. So minus 0.85. So that is going to be the start point, and the center point will be at 0.85 minus 0.85. The direction of the travel for the arc is still going to be the same based on our start point. And then we want to make sure that the yx is flipped as well. So in this case, the x is going to be negative, and this is going to be negative here. And again, let's go ahead and test it. Remember that when we're building these, it does not matter the direction that we're going. I'm just going to delete all of this. I'm going to rerun the script in this current sketch, and we should have built out the top and the bottom. So again, because we just redid the exact same block of code, this top one started here and it worked its way all the way around to here. And then this one started here and it worked its way all the way around the opposite direction. With the exception of this arc, the arc started here and worked its way down in the clockwise direction. But again, it doesn't matter. It doesn't matter. And if we add a line from here to here, we get a closed profile. So we know that all the points are connected. So the orientation or the order in which you build it doesn't matter. But now we've built the first half, so all we need to do is copy everything here 2 more times. And instead of just copying everything 2 more times, I'm going to take the entire thing, copy that, put a space down here, and then work with it. Now we have to remember exactly where we are. So the first 2 for loops, that's going to be for the first quarter. The second 2 are for the second, and you can see that these are tabbed in improperly, so we know exactly where we are. I'm going to add an extra space just for clarity, and we can see that the rest of it looks like it's okay. All right, so now we need to think about the positive and negative values. Okay, so we went from all positives, and then we went from the positive x, negative y. Now everything is in the third quadrant and they're both negative. So x is going to be negative and y is going to be negative. And then we need to figure out where this point is. So it's going to be minus 0.85 and minus 1. It's exactly opposite from our first one. So the numbers are still the same, which makes it easier. And then down here for the second for loop, where y and x are switched, that's still fine. But we just need to make sure that they're negative. So that should take care of the third quadrant. Now we just need to work in the fourth quadrant. So in the fourth quadrant, we're going to have negative x and positive y. So we just need to go through and we need to say negative x and delete the minus from the y, negative x, positive y, and we're going to do the same thing down here, and then I'll go ahead and fix the arc. So this will be negative and delete that. And now for our position, it's going to be this is the opposite quadrant of the bottom right. So it's going to be negative, positive, negative, positive. But the numbers are correct. So this is why it makes sense for us to just copy the whole first thing, because all we really need to do is flip the positive negatives around. So this is not it, but let's save it and let's double check what we have, and then we can finish off the last bit of this program. So again, let's go ahead and just delete everything we have. Just gonna select it. I can hide the origin, doesn't really matter there. We're gonna do 2020 AL, and now we've built the whole thing. It is a closed profile. So this is perfect at this stage. The last bit we need is the circle in the center, because these are gonna be able to be tapped in the center, they're gonna be hollow. So we need to make sure that we add that last piece, and we haven't actually built a circle yet. So what I want to do is I want to come down below all of my for loops. I'm going to tab in, because remember the tab is going to be important so that we're still inside of this try. And then we need to build out a circle. We haven't accessed circles yet, because if we go back up in our code, we added sketch lines and we added sketch arcs. We never added sketch circles. So I'm going to add sketch circles up here. I'm just going to say circles equals sketch dot sketch curves dot sketch circles. So once I have that, you see it's gray because we haven't used it yet. Now I have access to the circles that we need. So again, tab in where the for is. Now we can just do circles dot add by center radius. So tab in brackets, we're going to do adsk.core.point3d. And we're going to do .create, just like we did before. And inside of here, I'm just going to use 0, 0, 0. We're starting there as our center position, comma. Now we need the radius. Now, in this case, it's a 5 millimeter diameter. So it's we're going to have to do 0.25, because remember, we're in centimeters. And that should build out our circle. Now, one thing I did different is I didn't define the start point and the end point, or the center point and the radius. I simply just hard-coded the 0.3D directly inside of here. Whether you do it that way or whether you predefine it, it's up to you. For the start and end point of the line, we had to predefine it because we continually went through the array in the for loop and we accessed different values. And it was just easier to predefine a start point and an end point. And same thing for the arc start and center. It was just a little bit easier to do that. For this circle, we certainly could have used the 0, 0 coordinate. We could have defined something like circle center, and that would have been equal to adsk.core.point3d.create. And that would have just been 0, 0, 0. And then instead of having this inside of here, what we could do is we could simply just have circle center. It's exactly the same thing. It just depends on if you're going to repurpose the variables or if you want to hard code it in here. Or instead of doing that, we could have just, put 0, 0, 0. Potentially. It depends on what you're doing. Sometimes you have to create a 0.3D. Sometimes for like the radius value, I don't need a 0.3D. I can just put that value in. So let's go ahead and save this. Let's hop back into Fusion and let's test it. So I'm going to finish this sketch and I'm going to hide it and I'm just going to create a new sketch. Just pick a plane, go to Utilities, Add-ins, API 2020 ALL, and run it. So now you can see we've got our profile. This is exactly what we want. We could finish the sketch. We can extrude this in 3D. And now we have the solid. The next step of this process really is going to be based on your modeling approach. So the way that I'm going to do this is, again, another new part. I'm going to start a sketch, and I want to create a center point rectangle. So the center point rectangle is going to be the base of my frame. I'm going to give it some dimensions. I'm going to say it's 100 millimeters by 300 millimeters. The trick here is actually going to be, I'm going to hit escape. I'm going to turn these ends into construction by hitting X on the keyboard. And then I'm going to draw 3 more lines. So what I'm going to do is 1, 2, and 3. The little end pieces, those pieces there are going to be construction. If you can't actually select them, if you're having trouble, hold down the left mouse button and it'll allow you to go through the dialog to figure out which the sketch lines are. And then we need to think about this. If this is going to be the center of our 20 millimeter extrusion, then these little lines here need to be 10 millimeters. So the distance from here to here is going to be 10. And then that little line and that little line are going to be equal. I'm going to delete the original construction line so it's a little bit easier to see. I don't really care if this is fully defined for our example, but I just want to be able to see this. So we've got 10 millimeters here. You can see that this is flipping around, and that's because it needs to be a vertical line. This needs to be vertical, and that needs to be vertical, and now everything is happy once again. I'm not going to worry about this side. We're going to finish the sketch, and I'm going to show you the reason why we approach the project in this manner. So we're going to go to Construct, Plane Along Path, and we're going to just pick one of the edges. Now, the trick to this is the direction that the arrow is facing is normal for that plane. And what that means is if we sketch on this, X is going to be to my right and Y is going to be up. So we're going to create a sketch on this plane. We're going to go to our utilities. We're going to go to our add-ins, and we're going to run that API 2020 AL. It creates a sketch directly centered on that plane. And the reason why we did a plane along our curve or a plane along path is because the center point will always be based on the selected edge that we have. So now I can finish this. I can create a sweep. I can select my profile. And for my path, I can select this edge. We're going to say OK. We're going to bring that last sketch back. That was sketch 1. And I'm going to repeat the process over here. So we're going to create another plane along path. Select this. Doesn't really matter its position because we are going to be doing a sweep. If you're going to be doing an extrude, you might want to make it be on one side or the other. And then I'm going to create a sketch on this plane. Once again, we'll go to Utilities. We'll run our API 2020 AL. And again, we didn't talk about dimensions or constraints. This is 100% underdefined sketch, but I didn't really want to get so deep into this that we had to worry about those. As long as we don't move anything, the sketch is fine. But now we can go in, once more, we can create a sweep. And we're going to sweep along that shortened line. And the reason why we did the shortened line is because now you can see exactly where it ends. Now, in reality, what we should have done was extended this one out. But we've used those sketches to create a quarter of our frame. We can use things like push-pull, which is Q on the keyboard, to select this face and pull it out. And then for the distance, we can just select another reference. And then we can just mirror whatever we have. So if I go down and select mirror, I mirror the bodies. I take this, mirror it across here, repeat the process, take this body and mirror it across this plane. And then I'm going to use Q on the keyboard for press pull. I'm going to select both of these faces, pull them out to here. And fairly quickly, we created that frame. So if you were to manually model this, you would have to recreate that sketch. You might have to just copy and paste the sketch into a new sketch, or create one of these entities, make copies of the body and trim them down, extend them, whatever the case might be. There is one more case that I do want to show before we end this. I'm going to create another center point rectangle. And this is actually a downside to this method. So we're just going to create a rectangle. I am going to do the same thing by creating a plane along path. Just pick one of the edges, doesn't really matter. Create a sketch. Use my utilities, add-ins, API 2020 AL. Finish my sketch. And now I'm going to sweep this around the entire rectangle. And here is where this process falls apart a little bit. So if we select sweep, select that as our profile, and this is our path, it will go around the entire thing for you. The problem with this method for this extrusion is that's not how this part is built in reality. If you are using a profile of something like a 2x4 or some square tube or some angle, then your results might be a little bit better. But when we're designing this, or when we're programming this, I should say, we have to think long and hard about the way in which these are being created. Now, this corner could use a little bit of cleanup. For example, we could come in and select a couple faces and we could try to delete them. We could select that and delete it, select this and delete it. And you can see that we're able to just do a little bit of work and clean this up pretty easily. Now, in reality, we could say, well, we might cut those at 45 and build this in this manner. It just would be multiple bodies. We could do a little bit extra work and so on and so on. But hopefully you get the point that the way that you design your profiles, how they attach to your sketch origin, and what the end result or the end goal is going to be can really drive the functionality, whether or not it's good or bad, but can drive the functionality or the outcome for these programs. So to do a very quick recap, a very short, quick recap, we learned some basics about creating a sketch in Fusion, and that was the ability to actually add a new sketch and add sketch lines and rectangles to it. Then we learned about accessing the current active edit object, which is a current sketch that you're editing, and adding sketch lines directly to that sketch. That had some benefits because it easily opened up some of the add-in functionality where we can find things like add center point rectangle just by hitting sketch lines dot. From there, we took it a step farther and we learned a bit more about positioning our coordinates inside of an array, using a for loop so that we could iterate through all of those because we have a lot of repetition. It saved us a lot of work in terms of hard coding because we just really had to do a for loop once, create one arc, create a second for loop, and then copy that whole thing a couple times. This whole process did have an if statement in here that was running a check to make sure that we were in an edit sketch. So if we ever did come back and try to run this utility without being in a sketch, it says, hey, a sketch must be active. You need to be in a sketch. So once we go in a sketch, then we have the ability to actually run this. So just keep that in mind that we were really looking at this from a very general perspective. Obviously, we had a design in mind, the aluminum extrusion, which allowed us to look at things like arrays and for loops and working through the process of not having to manually or hard code everything. But at this stage, we know quite a bit about API, at least enough to make us dangerous. So we can do things like create user parameters. We can get some input from the user. We know how to create new sketches, access current editing sketches or sketches that are currently being edited. And we know how to create things like lines, arcs, circles, and rectangles. So from here, the next logical step is either to learn about dimensions and constraints on a sketch or how to automatically turn that sketch into a feature. There are a lot of sample programs in the API help that you can go through that do this sort of thing. If there is interest, I will continue on this series and continue to cover that. I don't really have a grand plan for going through all these videos, really kind of taking them one at a time. So user parameters was sort of the first thing. Sketches is the next thing. If there is more input, I know a couple people have commented on what they want to do, things like STL exports and things like that. If there's a consensus on what the next step should be, then please leave a comment for me or send me an email. But thanks for watching, and we'll see you in the next one.